All right, so here we go. Another graphing the linear inequality in two variables. And they give us x minus y is less than -3. So again, let's go ahead and not let this inequality fool us or scare us. We're going to go ahead and treat this as a regular equation that we're used to graphing. And so we're going to pretend this says x minus y equals -3, just for the purposes of getting a line on our grid here. And again, we don't want to forget that if it is less than or equal to or greater than or equal to, we're using a solid line, so a solid line. If it's greater than or less than without that equals, we're using a dotted line. And so in this case, because this is a less than, we're going to be using a dotted line. All right, so again, we can either choose to solve for the x and y intercepts, or we can come up with two other points, or we can go ahead and just do our slope-intercept form, y equals mx plus b. And I think I'll go ahead and do that here. So we're going to subtract x from both sides, and that's going to leave us with -y is equal to -x minus 3. And solving for y, we'll divide by -1 on both sides, which is going to give us y equals x plus 3. All right, so now that we have an equation in slope-intercept form, this makes it nice and easy to plot, right? Because we know what our y-intercept is. We know that we're going to go to 3 on our y-intercept, put our first point right there. And then we're going to use our slope, which in this case is a +1, to find our next point. So if our slope is 1, that means we're going to go up 1 over 1. And again, we can do that an infinite number of times if we want to continue to get additional points on this line, but we only need 2 points. And we're going to go ahead and connect now these points with a dotted line, because that's what our inequality tells us to do. And so what does that look like? Well, we're going to have a dotted line that looks something like that. And now, because we are graphing an inequality, we know we have to shade. We either have to shade above this line or below this line, depending on what our test point tells us. All right, and again, the easiest test point to use is that origin of 0, 0. And you can always use 0, 0 so long as your line does not go through that point. If your line does happen to go through 0, 0, choose another easy point to work with. 1, 1, or -1, -1, or something simple. Don't choose, don't choose anything that gets too crazy, but you can choose any point so long as the point is not on this line. And we can clearly see the graph, our graph does not go through 0, 0. So let's go ahead and choose 0, 0. And we're going to take 0, 0 and plug it into our original inequality and see whether or not we get a true statement. So again, this is our x and this is our y, right? So let's plug that in. So we have x minus y, so 0 minus 0 is less than -3. Well, 0 minus 0 is just 0, less than -3. And is this a true statement? Is 0 less than -3? Well, no, this is a false statement, isn't it? 0 is not less than -3. And so since our test point in this case was below the line and we got a false statement, that means any point we choose below this line will also give us a false statement. And we don't want to shade where the answers are false. We want to shade where those points, when we plug them in, make our inequality true. So we're going to shade on the opposite side of our test point, which in this case is going to be above the line. And so we shade above, because if we chose a point from above the line, we would get a true statement. And we can go ahead and test that if we want, just to confirm. Let's go ahead and choose about -5, +5, just to prove what we've done here is accurate. So we're going to test this point here. And again, you do not have to test above and below the line. You only have to test one point. And as soon as you test that point, you know whether or not to shade above or below. But just, because we're just getting into learning this, we want to go ahead and just verify for sure. So we said we're going to test -5, 5. All right, and again, this is our x, this is our y. So let's plug this information into our original inequality and see what happens. All right, so we get negative 5 minus 5 less than negative 3. Well, negative 5 minus 5 is negative 10 less than negative 3. Is this a true statement? Indeed it is. Negative 10 is in fact less than negative 3. And since this was a true statement and the point was above the line, we know that any point we choose above this line will also give us a true statement. So we shade above the line. All right, so the key takeaway when you are graphing inequalities and choosing a test point is you shade where the points make your inequality true. All right, let's go ahead and take a look at number 22 in the next video. Joe Brownlee with Palm Beach State. Thanks for watching.